Okay, guys, we're starting chapter 7 now, which deals all with exponents. So in section 1, we're going to talk about multiplication properties of exponents. So previously, we did evaluate expressions with exponents, and now we're going to multiply things called monomials using the properties of exponents and simplify expressions using multiplication properties of exponents. So our new vocabulary are those couple words, monomial and constant. I believe constant came up before, so you should kind of be familiar with that, but we'll go over it again. So a monomial is a number, a variable, or the product of a number in one or more variables with non-negative integer exponents. It has only one term. So in the formula to calculate the horsepower of a car that's talked about over here in this setup example, the term W times the quantity W over 234 cubed is a monomial because it's either a number, a variable, or the product of a number in one or more variables. So like you have V times, or W times V over 234 with non-negative integer exponents. The exponent is an integer, it's not negative, and it has only one term. Remember, terms are separated by addition or subtraction, so that's one term. An expression that involves division by a variable. See, division by a number is okay, because you could think of that as multiplying by, like V times 1 over 234. So you're multiplying by a number there. But if you're dividing by a variable like A times B divided by C, that's not a monomial. A constant is a monomial that is a real number. The monomial 3x is an example of a linear expression since the exponent of x is 1. Remember, anytime there's not an exponent written, it's understood to be a 1. A constant is a monomial that's a real number, like 2, 2.7, negative 4.6, square root of 3. Those are all constants that are monomials. And if you know things about language, mono means one, and nomial means term or number. Okay, so it's just one term is what monomial means. The monomial 2x squared is a nonlinear expression since its exponent is a positive number other than 1. Like x squared is not power of 1. All right, so let's determine whether each expression is a monomial, right? Yes or no, and then explain your reasoning. So letter A, 10. Is that a monomial? You betcha. It's because it's a constant, and it's just a number and nothing else. Okay, how about B, f plus 24? This is not a monomial because it has addition, so it has more than one term. In fact, this has two terms. It's actually the sum of two monomials, but the whole expression together is two terms, so that's not a monomial. H squared? Yep, that is just a variable to a non-negative integer exponent. Okay, and J, part D. Yes, just variables by themselves are monomials because it's a variable and the exponent on the J is understood to be a 1, which is a non-negative exponent. Okay, here's some for you to try. Go ahead and pause the video. All right, we're back. 1a, is that a monomial? No, it's because the expression has addition and more than one term. 1b, is that a monomial? Yes, because even though there's a bunch of different variables in it, they're all products. So this is the product of a number and one or more variables, and any of the exponents are non-negative integers. How about C? Yep, that also is a monomial because it's the product of variables, and division by a number is okay because you can think of that as times 1/2. The exponents are non-negative, so we're good there. How about D? No, you're not allowed to have division by a variable, so that automatically rules it out. So recall that an expression in the form of x to the nth power is called a power and represents the result of multiplying x by itself n times. So x is the base, and n is the exponent. Okay? So the word power is also used sometimes to refer to the exponent. So let's look at this a little bit more. If you have 3 to the 4th power, the base is 3, the exponent or the power is 4, that means multiply 4 factors of the base together. 3 times 3 times 3 times 3, which would be 81. Okay, so by applying the definition of a power, you can find the product of powers and look for a pattern in the exponents. So, for example, if I have 2 squared times 2 to the 4th, what does that really mean? That means multiply 2 2's together and then multiply that by 4 2's multiplied together. Well, really, how many 2's are you multiplying together? You really have 6 factors of 2 multiplied together, so you can simplify that. 4 cubed times 4 squared. Well, what does that mean? That means multiply 3 factors of 4 times 2 factors of 4, and you would have 5 factors of 4 multiplied altogether. These two examples demonstrate the property for the product of powers, and here's how it works. Basically, when you multiply two powers that have the same base, you add their exponents, because the exponent on the first power means multiply that many of that base together. And then if you're doing the same thing with another base, but maybe a different exponent, you're multiplying that many more. Well, if you're multiplying those two together, you're really multiplying all those factors all at once. So if I have 3 factors of b times 5 factors of b, that's really 8 factors of b multiplied together. So you could just add the exponents. Okay? So here's an example for us. Let's simplify 6n cubed times 2n to the 7th. So first thing you want to do is, one property of multiplication is whenever you're multiplying many factors together, you can multiply them in any order. For example, if I had 2 times 3 times 4, you could do 2 times 3, which is 6, and then 6 times 4, which is 24. Or you can multiply the 2 times 4 first and get 8, and then multiply that by 3, and you'd still get 24. So what we can do is regroup these problems, since it's all just multiplication, so that you multiply the coefficients, 6 times 2, and then the variables, the n cubed times n to the 7th. Well, the 6 times 2 is easy. 6 times 2 is 12. And then I can use the product of powers property. This base, remember, this means 3 factors of n times 7 factors of n. Well, altogether, I'd have 3 plus 7, or 10 factors of n. And 6 times 2 gives you 12. So the answer is just 12 times n to the 10th. We're not solving an equation here, because the original question is just an expression. Okay, you're not solving for anything, you're just simplifying. Alrighty, I don't know what n is, so the best I can do is simplify the factors that have an n in them, but I can't figure out what n is. They didn't tell me anything to plug in for n, so I'm done. How about this one? Okay, we're going to group the coefficients in the variables. This one right here is understood to have a 1 in front of the p here. That's where this one came from. Okay, so it's basically 3 times 1, or just 3. You group the p's together, so you have p times p cubed, and then t to the 3rd times t to the 4th. Now, a lot of people mistakenly think that p times p to the 3rd is just p to the 3rd again. But remember, if there's no exponent on a variable, it's understood to have a 1. Okay? Plus, you could think of it like this. P cubed means multiply 3 factors of p, and if I do that and multiply another factor of p, how many p's would I have? Right, I'd have p to the 4th. So applying the product of powers property, I'd have p to the 3 plus 1 times t to the 3 plus 4. So my final answer is 3p to the 4th times t to the 7th. Alrighty, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So 2a, I can regroup and do 3 times 7 times y to the 4th times y to the 5th. 3 times 7 is 21. Then you can do y to the 4 plus 5. And that'd be 27 y to the 9th. Again, we're not changing the multiplication to addition. That's not what we're doing. We're using the property that this means 4 y's multiplied together, and the y to the 5th means 5 5 y's multiplied together. So altogether, you're going to have 9 y's multiplied together. Okay, so 27y to the 9th. This one, here we go. You have -4 times -6, and then you have r times r to the 5th. Try to squeeze this all in. X squared times x squared, and then t cubed times t. Okay, -4 times -6 is going to give you 24. R to the 5th times another r is going to give you r to the 1 plus 5. X is going to be x to the 2 plus 2. And t is going to be t to the 3rd plus 1 more t. So you have 24 r to the 6th, x to the 4th, t to the 4th. And that's your answer there. Alrighty? Cool. All right, so we can use the product of powers property to find the power of a power. So like when you have a power on top of a power raised to a power. In the following examples, look for the property, the pattern in the exponent. If I have 3 squared to the 4th power, that means multiply 4 factors of what the 4 is on. The 4 is on the 3 squared. So that's going to be 3 squared times 3 squared times 3 squared times 3 squared, which means I'm going to have 3 to the 2 plus 2 plus 2 plus 2, which is 3 to the 8th. If I have r to the 4th cubed, that means multiply 3 factors of r to the 4th together. So r to the 4th times r to the 4th times r to the 4th, which would be r to the 4 plus 4 plus 4, which is r to the 12th. Do you see a shortcut? These examples demonstrate the property of power of a power. When you have a power of a power, you just multiply the exponents. Like the shortcut is 3 squared to the 4th power, just multiply the 2 and 4 and you get 8. R to the 4th to the 3rd power, multiply the 4 times 3 and you get 12. Okay, so here's one for us to try. Let's simplify 3 cubed, quantity squared, quantity to the 4th power. Okay, so if I work from the inside out, 2 cubed squared is 2 to the 3 times 2, which is 2 to the 6th. But that whole expression, that whole factor is raised to the 4th power, which really means 4 factors of 2 to the 6th. So it'd be like 2 to the 6th times 2 to the 6th times 2 to the 6th times 2 to the 6th. Multiplying exponents, I get 2 to the 24th. All right, here's one for you to try. Go ahead and pause the video. Okay, we're back. So 2 squared to the 4th power. Well, if I multiply inside, I would do 2 squared is 2 to the 2 times 2, all that to the 4th, which is going to be 2 to the 4th power. Now I do power again, which is 2 to the 4 times 4, which is 2 to the 16th power. Okay, we're just simplifying it. You don't have to like plug into your calculator 2 to the 16th and figure out what that is. It can be a pretty large number, actually. All right, guys, that's it for this video. Stay tuned for the second half of this section, and we'll see you there.